Okay, this is going to be the final stoichiometry lesson, stoichiometry number 3. This is where we are going from mass of a reactant or product and trying to determine the mass of another product or reactant. So it's a gram to gram conversion. So in this case, I'm going to say we're putting in 91.3 grams of oxygen. And what we're trying to find is how much oxygen reacts with NH3, which is ammonia. Okay, I could also say with this many grams of oxygen, how much nitrogen dioxide is formed. Or with this many grams, what mass of water is formed. In this case, I'm just going from mass of oxygen to mass of ammonia. So it's a gram to gram stoichiometry problem. So my roadmap is that I'm going to go from grams of oxygen and I'm going to convert that to moles of oxygen. Because in order to talk one substance and start talking about another new substance, I need to get both in terms of moles. So once I have moles of oxygen, then I can use my mole ratios and convert to moles of ammonia. And then my last step is that I want mass of ammonia. So for a mass-to-mass stoichiometry problem, these steps are really always the same. You go grams of your given to moles of given to moles of what you want, moles of what you want to grams of what you want. This right here is your mole ratio step using the coefficients. I'm going to go ahead and start with 91.3 grams of oxygen, and I'm going to convert that to moles of oxygen. In order to do that, I have to say for 1 mole of oxygen, that's 16 times 2. So that's 32 grams for 1 mole of O2, because one molecule is really 2 atoms combined. So 16 times 2 is how I get the 32. All right, so I'm at moles of oxygen. So I'm going to keep going though and not do separate steps with these, just so that you see the kind of the most efficient way to do this type of problem. So my next step is moles of ammonia. So I could see, let me go back here, that my grams of oxygen cancels my grams of oxygen. So at this point, if I were to calculate 91.3 times 1 divided by 32, I have moles of oxygen. So to get to moles of ammonia, I need to look at this mole ratio. I need to put moles of oxygen on the bottom, and I need to put moles of ammonia on the top. So these numbers here are what the heart is, and that's the heart of the problem where I can actually start converting to the substance I want. Okay, so that's the orange. That's this number here and this number there. That's where I get those numbers. So the Betty Crocker recipe says 4 moles are required for every 7. So here I see moles of oxygen, and moles of oxygen will cancel. And this is where you have to be careful how you place these numbers. And the one I want is going to be on the top. All right, so the last step, if I were to calculate this out, 91.3 times 1 times 4, divided by 32, divided by 7, I would be left with moles of ammonia. I don't want moles of ammonia. I want grams of ammonia. So in order to finish the problem, I put moles of ammonia on the bottom. 1 mole, what is the mass? We would take nitrogen and hydrogen. There's 1. There's 3 times 14. Hydrogen times 1 So I get 17 grams per mole. So I'm going to put 17 on the top. So when I compute this, I'm going to move the paper down. I'm going to take on my calculator 91.3 times 4 times 17. 91.3 times 4 times 17. I'm going to do that again. Divide it out by 32. Divide it by... Shh. Quiet in the background. Divide it by 7. So I end up with my final answer being 27.7 grams of ammonia. Now, I always have to pay attention to my sig figs. My original problem was right here. It had 3 sig figs, so my answer should only have 3, and that's with rounding. So the correct answer is 27.7 grams of ammonia. And that's the entire problem for a mass-to-mass stoichiometry.